All right, IBAISL2 fans. We're back today to talk about Pearson's correlation coefficient. We already talked about correlation in our last learning target, but now we did it kind of by eye, that you can like look at a graph, and if they're scattered tightly, that's strong correlation. If they're looser, that's not great correlation. We're going to talk about a better way to describe correlation with the certain letter R. But before we get there, let's talk about these types of correlation that I have on the screen right now. So, you can use words to describe these. First of all, both of these guys are linear on the top. Both of these are linear because they're kind of in a straight line. So I would describe the upper left graph, this one right here, as having like an uphill trend, and they're like fairly packed around a line. So I would call this like strong linear correlation. Also, it's going uphill, so I would say strong positive. We'll talk about the direction a little bit more in some future graphs. This guy over here, I meant for the dots to be like perfectly on a line. So sometimes they'll call this perfect linear positive correlation. Now this graph right here, it does have a strong correlation, but notice that it's kind of exponential. We're not going to say that it's exponential or anything like that. We'll just say that it's non-linear. Same thing with this graph right here. This is also non-linear, but I meant for it to be like, you know, on this one over here, I put some dots that are kind of outside of it, so it's like, it's not perfect. We would probably call it strong. Strong non-linear correlation. But with this graph, I tried to perfectly put them on an upside down parabola. So this is perfect non-linear. Now, I noticed there's a couple problems that come up in your homework where they kind of get at like the correlation versus causation. Remember my example from the last video about ice cream consumption and shark attacks? They are very highly correlated. Like the more ice cream that's consumed in a coastal town, the higher the shark attacks are. Now, this is high correlation, or strong correlation, I guess I should say. But this is not causation. Remember, causation would mean like eating ice cream causes a shark attack, and that's not true. An example of causation would be like smoking and lung cancer. Been a lot of studies that show that that's 100% true. The more you smoke, the more higher chances you have of getting lung cancer, and so they're high correlation, strong correlation, but there's also causation there. The smoking causes the lung cancer. Now, there's this number for correlation that can tell you how strong a correlation is. It's not, I feel like it's so funny in like when you first introduce it, because you just look at a graph and you're like, oh yeah, it looks kind of strong or moderate or weak or something like that. So there's an actual number with Pearson's correlation coefficient. Oh yeah, it's called Pearson's, and it's this lowercase r. That's what we use for the correlation coefficient. R can go anywhere from -1 to +1. Anywhere in between. It's usually a decimal reported out in between. So with this first example here, this is a very strong correlation, but it's also negative. So I would say this is a strong negative. If you were to look at the Pearsons for this, this would be like an R equal to -1.0 because it's going downhill and it's very nicely correlated. Now this one is still going downhill, but it's not as closely packed. So you would call this a moderate negative. moderate negative, and this could have like a Pearson's of, and I'm just going to make this up. I don't know what it actually is, but you know, it's probably something like negative 0.6 or something like that. Now this guy is still kind of headed downhill. Like if you look at the trend, it's kind of going this way, but it's very loose. It's not very tightly packed around the line. So we would call this weak sauce, weak negative correlation. This might be something like a negative 0.2, something like that. Now the flip of that, if it's going uphill and it's tightly packed, this is a strong positive. This would be something like an R equals 1.0. That would be also called like a perfect correlation. 1 and -1 are like perfectly correlated. The next one here is a little bit looser, but it's still pretty good, and it's going uphill, so we'll call that a moderate positive correlation. This could be something like a, well, we'll just keep it like 0.6, positive 0.6, and then this guy is weak, so weak positive correlation. Call that like 0.2. The last situation you can have is this guy right here, where it's just like the snowstorm, like there's not really a trend. You can't really say it's going uphill or downhill. It's not, yeah, it doesn't have a lot of correlation. So we'll call this no correlation. This would be like an R equal to 0. 0 means that there's no strong relationship at all. Now, there is a formula to be able to find the R value to get like the 0.6 or negative 0.5 or whatever. It's covariance, which is S sub xy, over the standard deviation of x times the standard deviation of y. This whole, here, let's color coordinate this, or color coordinate it. This whole top is this whole equation right here. So you could like put all of that up in there into the equation, and then this standard deviation of x you would put right here, and then all of the standard deviation of y would go right here. So it's like 3 equations rolled into one. Now, here's the good news. If you are not writing an IA, you don't really need to do it by hand in this course. I'm going to show you guys on that other video how to find it on a calculator. So check out that video. If you are writing an IA, I think they expect you to kind of show by hand how Pearson's work. So I made sure to put this in your notes. Here's an example of some scores from students in a math class and a biology class. Like, you know, this score right here represents a student that got a 25 on their math test and a 20 on their biology test. What we're going to do is sketch a scatter plot and then comment on the visual correlation and then actually find R. So the way you do that, I showed you guys how to find a scatter plot on a TI graphing calculator on my other video. So punch it into, oops. Punch this into L1 and this into L2, and then make sure your stat plots are on, and then you should see something like this. I'm just going to do a sketch of what it kind of looks like. 20, so it's probably like around here. I think it looks something like this. So you notice that there is kind of an uphill direction here. Yeah. Visually, I would say that it's pretty strong. I mean, you know, this little point right here is not that great. It's not on the line, but it's fairly clustered. So I'm just going to say strong, positive, linear correlation. That's just visually. Now, put L1 and L2 into your calculator and then run lin/reg on it, and it's going to spit out that R value as long as you have your diagnostics turned on. If you don't understand a word I just said, you need to watch that other video in this lesson about how to find the R Pearson's correlation coefficient on a graphing calculator. But if you do run ln-reg, you should get this, that R is about 0.86. This is indeed a strong correlation because that number is getting close to +1. Remember that the closer it is to +1 or -1, the stronger it is. And the closer it is to 0, the weaker it is. Now, you might look at this number right here and be like, well, okay, but what if it was 0.8 or 0.75 or 0.7? Like, would I still call it strong? Where's the cutoff, Jolly, between strong and moderate and weak? Well, in general, know that towards 1 and -1 is stronger and towards 0 is weaker. But there actually is a table that tells you how to describe it based off the Pearsons. So if you take the absolute value of the Pearsons, if it's between 0 and 0.25, that's very weak. If it's between 0.25 and 0.5, that's weak. If it's between 0.5 and 0.75, that's moderate. If it's between 0.75 and 1, that's strong. And then if it's R, perfectly equal to 1, then it's perfect. Okay, you guys, good luck on your homework.